Doppler cloak. Hiding moving objects from radar, a new Doppler cloak has been developed that can render moving objects invisible to radar systems by making them appear stationary. This technology manipulates radar signals to exploit how these systems process information, offering a novel stealth solution that could supplement or even replace traditional radar-absorbing materials. How the Doppler cloak works: the device operates by tricking radar into believing a target isn't moving, causing it to be filtered out as static clutter. Most radars ignore stationary objects, and this cloak leverages that weakness. This differs from conventional stealth, which focuses on reducing how much radar energy an object reflects back. Instead of reducing reflection, the Doppler cloak cancels out the frequency shift caused by movement. Radars detect motion through this Doppler shift, a change in the frequency of the reflected signal. By altering the phase of incoming waves, the cloak makes a moving object mimic stationary clutter like trees or buildings. Metasurface technology. The core of the Doppler cloak is a metasurface, an ultra-thin material engineered with tiny structures that control electromagnetic waves. These surfaces can bend, absorb, or shift waves in ways natural materials cannot. The team's prototype uses a circular metallic disc with varactor diodes that adjust capacitance in real time to shift the frequency of incoming radar waves. This is the first demonstration of a cloak working with frequency-modulated radar, the standard in modern systems. Unlike previous research using simpler continuous wave signals, tests show the prototype suppresses Doppler information across a 50 MHz bandwidth at approximately 350 MHz, while also reducing radar cross-section for an extra stealth layer. Challenges and future developments. While promising, Doppler cloaking faces hurdles. Metasurfaces need to conform to curved surfaces, requiring integration with sensors that detect radar signals in real time. The technology is near practical use, but needs further development to become conformal and integrate sensing capabilities. Professor Shawnawa's Bureaucur estimates the technology could be ready in 5 years, with the most significant challenge being sensor integration. The research suggests this approach could serve as an addition to existing stealth methods or a cost-effective alternative for platforms where traditional reduction isn't feasible. Beyond stealth, Doppler cloaking has potential applications beyond military use. Metasurface designs could enhance telecommunications by manipulating signal frequencies for more efficient data transfer. The principles could also be adapted for higher frequency systems, opening opportunities in other fields. The successful demonstration of a cloak that hides motion from real-world radar waveforms marks a milestone in stealth technology research, offering both complementary and cost-effective solutions for various platforms.